Alright, I'm still going over the Unit 0 practice test, and I'm starting with question 4. So here we have 1 liter aqueous solution contains 0.3 moles of KBr, 0.6 moles of sodium bromide, and we want to know the minimum number of moles of lead nitrate that must be added to precipitate out all of the bromide ions. Okay, so what I have is I have a couple sources of bromine ions, right? Bromide ions. And I'm adding lead nitrate. And if I'm precipitating it out, that means that the lead is going to be with the nitrate. So I'm going to end up with PbBr2, and that's going to be a solid, right? And so just to make sure this is balanced, I'm going to need 2 of these. Okay. So let's treat this like an ICF table, and what I'm trying to find is the moles of this that I'm going to need. So first I have 0.3 moles of KBr, and when that breaks up, I'm going to get 0.3 moles of Br, right? And same thing, if I have 0.6 moles of sodium bromide, I'm going to have 0.6 moles of bromide there. If I add these together, I'm going to start with 0.9 moles of bromine. So I'm going to put my 0.9 here. And so if I have 0.9 of this, and I'm going to use it all, or precipitate it all, then I need half as much of this, or 0.45 moles. So the answer is E. Alright, question 5 says, what is the final concentration of barium ions in solution when 100 milliliters of barium chloride is mixed with 100 milliliters of 0.05 molar sulfuric acid? Alright, so let's just make sure we know the balanced equation. I'm going to get barium sulfate, which will be a solid, and HCl. I'll get 2 HCl. Okay, so the final concentration of barium ions in solution. Okay, so this is a limiting reactant problem. I'm going to make barium sulfate here, but there won't be any ions. So what I'm looking for is if I have leftover of this, because that's would be the only source of barium ions. Okay. So I have 100 milliliters of 0.1 molar. So, because molarity is moles over liters, moles is molarity times liters. So I have 0.1 liter times 0.1 liter, and that is going to be 0.01 liters. Not liters, 0.01 moles, right? And I have 100 milliliters of 0.05, 100 milliliters of 0.050 molar H2SO4, so that's going to be 0.1 times 0.05, which is going to be, I'm just going to move the decimal place one. Okay, so this is going to be 0.005. Okay, now these are, in here is a 1-to-1 ratio, so I'm going to be limited by the amount of H2SO4. So I'm going to have 0.005 moles of this, which will get consumed, and I'll lose 0.005 of this, which means I'll have 0.005 left of this and none of this. Now I will get some barium sulfate, but like we said, it's all gonna precipitate, so I'm not gonna have any ions of barium in there. So I have 0.005 moles of barium chloride, which means I have 0.005 moles of barium, right, because there's 1 barium in each barium chloride. But I need to find the molarity, the concentration, right, moles over liters. And I have 0.005 moles. And let me see, I have to look at the total concentration. 100 milliliters plus 100 milliliters is 200 milliliters, which will be 0.2 liters. Okay. Alright, so I think about 0.2 as 1/5, right? So if I have 0.005 over 1/5, then I can take that's equal to 0.005 times the inverse of this, which is 5 over 1, and I'm going to get 0.025 molar. Tough problem. All right. Let's take a look at number 6. Which of the following substance is a strong electrolyte when dissolved in water? So a strong electrolyte is anything that completely forms ions in solution, completely ionizes. And what completely ionizes are strong acids, strong bases, and any soluble ionic compounds. Okay? Soluble. All right. Ethanol is molecular, it forms no ions. Acetic acid is a weak acid. Sodium nitrate is a soluble ionic compound, so it's going to be sodium nitrate. Sucrose is a molecular compound, forms no ions. Ammonia is a weak base. It will form some ions, but it will be a weak electrolyte, so the answer is C. All right, when I have 70 milliliters of 0.3 molar sodium carbonate is added to 30 milliliters of 1 molar sodium carbonate, the resulting concentration of sodium ion is, okay, so I'm trying to find the concentration of sodium, so that's going to be the moles of sodium plus over the liters of sodium plus. So I first have to find the total moles of sodium plus ions I have, and then divide it by the total combined volume, because those sodium ions are in water that's combined. Alright, so if I have, for sodium carbonate, I have 70 milliliters, which is 0.07 liters, times 3 molar, times 3, so that's going to be 0.21 moles. And for sodium bicarbonate, or sodium hydrogen carbonate, I'm going to have 30 milliliters, which is 0.03 liters times 1 molar. That's going to be 0.03 moles. If I add them together, I get 0.24 moles. And if I divide that by the total number of liters, I have 70 milliliters plus 30 milliliters, which is 100 milliliters. So if I divide this by 0.1, it's the same thing as multiplying this times 10. So my answer is going to be 2.4 molar, right? Because 0.1 is 1/10. So if I flip this, multiply it times this, I get 2.4. All right, number 8. What number of moles of O2 is needed to produce 14.2 grams of P4O10? All right, so the first thing I'm going to need to do is find the balance equation. So I'm going to have P plus O2 is going to give me P4O10. I'm going to need 5 of those and 4 of those. Okay. The only weighable amount I have to start with is 14.2 grams of P4O10. It tells me the molar mass is 284 grams of P4O10, is 1 mole of P4O10. And for every 1 mole of P4O10, I need 5 moles of oxygen. Okay, so let's see what we can do using some mental math skills. Let me just get that marker to be red. Okay, so 14.2, if this was 142, this would be 1/10, right? So this is double that, so it's going to be 120. This is going to divide to 1, and this will be 20. Then I could take 20 and 5, and that's going to simplify down to 1 over 4, which is 0.25 moles. So that's going to be my answer. All right, we're going to stop there for this one, and I'll pick up on question 9 in the next podcast.